Robert Scribbler here with the OBX Wave Report, and thank you for joining me for a special edition of our Wave Report where we cover all things waves, weather, climate, and beach lifestyle. And lately, we've been covering a lot of weather and climate news, with California getting slammed by a succession of storms out of an atmospheric river aimed directly at the state from the tropics, and upon which are riding a series of storms that just keep running in and causing extreme weather conditions periodically for the state. At this point now, we've had multiple extreme storm events for California, and right now you've got flooding in various locations up across the state. I believe now 36 million people are under flood watch. The mountain regions are expected to receive yet another heavy snowfall, in some locations up to 5 feet. And many school districts have closed as President Biden approves an emergency declaration for the state due to the ongoing series of extreme events. I am going to show you guys some aspects of the system based on what the models can show us. And this particular system right now is, I'd say, it seems to be a very rainy system. It also earlier on apparently was a very windy system, although the models didn't resolve the extreme wind speeds that I'm getting reports of from news sources like CNN, for example, which is providing reports of up to 100-mile-an-hour conditions in California associated with these storms from the atmospheric river. So worth noting that the models do provide us with a lot of information, but on the ground information is, of course, always more accurate, even though the models are also very useful. I do want to provide you with a little bit of a model summary of what's going on, and then also talk about what's expected for the coming week for California as well, even as California right now is weathering yet another extreme event. And we're also going to look at some present conditions as even as we look at forecast conditions. So right now, let's look at some present conditions. For the wave models, the waves are still pretty high off California. It's not as crazy as, for example, what we've been getting in the wave models off Ireland, but still very high waves in the range of 15-foot significant waves for parts of Northern California, ranging down, and this is in the near offshore environment, to 12, ranging down to 12-foot significant wave heights for Central. And then for Southern California, things are a bit calmer here with 4 to 6 foot significant wave heights in the near offshore environment. You get out here into the shipping lanes though, and the waves just jack up to 15 to 18-foot significant wave heights. In a stormier region, we've got near 25-foot significant wave heights. And then in a powerful storm right here south of the Aleutians, we've got significant wave heights in the range of 40 feet, and this is way out in the shipping lanes. But looking at these series of storms, you can kind of trace the influence of the atmospheric river pointing at California, and all these storms swirling up off of the atmospheric river and just getting into some pretty extreme intensity here. I'm going to show you some other model pictures. So we're going to go down to the air level and look at some winds here. It's worth noting that the wind speeds in the models are near gale force just offshore of south central California. And we've got some powerful winds coming in here in the near gale force range off of Washington and Oregon as well. Further out, we've got gale force, strong gale force conditions. And then in association with a powerful low pressure system south of the Aleutians, we've got near hurricane force winds, which very easily show up in the model. It's likely that these are hurricane force winds down at the surface. The model is a bit more, what's the word, broad brush. So the intensity of the wind speeds tends to be higher at certain points. So we can see these series of storms in the wind, and then in the wind models, and then looking at, I'm going to show you water vapor, some precipitable water here. And so you can see I'm just going to zoom way, way out. So the tropics here are always very moist, and you've got a lot. It's because it's warmer, and particularly over the oceans, that those warmer airs create more evaporation. So you've got all this, massive amount of water vapor here at the tropics. What ends up happening in an atmospheric river is you get this tropical water vapor getting pulled up into this stream that you see, and it's a bit wavy moving across the Pacific. You can see, so the drier air is here over Hawaii and off the west coast. And what you would typically see is just generally broadly drier conditions here. But what you have now is just this river of moisture streaming out of the tropics, moving north of Hawaii, and then continuing on through the central and eastern Pacific, and then streaming into California here. And we've seen this feature here, this atmospheric river, for days and days and days. And this is, what's bringing in the stormy weather to California, and what's creating this extreme swing from dry conditions for California, for parts of California, to very moist, heavy precipitation conditions for California as well. And it's one of the climate features that climatologists and climate observers have talked about a lot is not only is there um, more likelihood for intense events in the climate system as the Earth system warms due to fossil fuel burning, but you also get more of a variance, so more of a variance between extreme precipitation and extreme drought. And in particular, California appears to be a location where that feature of a changing climate tends to have a more noticeable effect because, I mean, a changing climate is not even. It's certain places experience the conditions of a changing climate more acutely. And from the standpoint of extreme precipitation swings, California seems to definitely be one of the locations for that. And one of the reasons why we see that, and I'm just speaking generally, I'm not going to get down into all the various specifics, but um, is that as the climate system warms, you get more evaporation off the land surface. So the evaporation, so you get hot land, for example, with the sun streaming down and the temperatures are higher, and so you get faster evaporation off the land surface, and that can create more extreme drought conditions. But the moisture that comes off the land and off the oceans due to that increased rate of evaporation has to go somewhere. And where does it go? When it comes to evaporation off the ocean surface and the land surface, that lift in the atmosphere caused by that evaporation has a name. And that name for weather types is convection. And it is that lift, often of moist air or evaporative lift, that can tend to fuel extreme storms. And over land, the convective lift coming off of lands that are evaporating water into the air can create thunderstorms. And the more convection in the form of that lift, the more energy there is there to boom, really push up the cloud tops and create all the updrafts and that then turn into swirls. And so you get the potential for more extreme thunderstorms, which can create more extreme rainfall events and other extreme events associated with thunderstorms. And then over water, you get that lift too. And that lift is a component. It's not the only component, but it's a it's an energy component of tropical cyclones. So you can get more extreme tropical cyclones with that extra lift. And in this case with California, you've got this atmospheric river of moisture where the evaporation is happening and you get the extra moisture in the air. So the evaporation happened in the tropics. The water got injected into the atmosphere. So you've got all this, convection, you've got this lift, and you've got the moisture. And when you get these unstable swirls, coming out of the northern sections of the world here, out of the Arctic and out of the colder land regions, the moisture gets swirled up into these storms. Because of the extra energy, they can tend to intensify more. And then you just have all this extra rain and snow coming in to California because you got this extra stream of moisture that's coming out of a warmer than normal Pacific Ocean. Even though the tropics right now aren't necessarily warmer than normal in this region, they are warmer than normal in this region here in the Western Pacific, and they're considerably warmer. The ocean waters are considerably warmer than normal in the Northern Pacific. And so these warmer than normal conditions help to feed that stream of moisture. And let's go down to the ocean and surface and look at the sea surface temperature anomalies. Now we're going to talk anomalies. We're not talking sea surface temperature directly. We're talking about the variance from the normal. So when you see reds here and yellows, that's a variance from the normal in the range of hot or warm. And when you see blue, you see variance in the normal from the normal in the range of cool. And for the equatorial Pacific right now, conditions are in what they call a La Nina state. And La Nina is a part of a regular climate cycle that we see in the Pacific. So La Nina is when the equatorial Pacific and the eastern equatorial Pacific tends to be cooler. Although right now it's starting to warm up a little bit, but you still have the influence of La Nina generally across the equatorial Pacific, where you have cooler than normal sea surface temperatures. And that's what's happening in the eastern Pacific. But out here out west, where the river of moisture is coming from, the Pacific is warmer. And that's what you also see in La Nina, because the La Nina tends to focus the cooler than normal waters off of South America and out here closer to the central Pacific. And then the warmer than normal waters tend to pool up here in the Western Pacific. And that's what we're seeing. We're seeing sea surface temperatures in the Western Pacific in the range of 1, and then out here off of the Philippines in the range of 1 to 2 degrees. This is Celsius. Let's flip over to Fahrenheit. So looking at Fahrenheit, we're looking at 1 to 3, maybe 1 to 4 degrees. Let's look here. I saw a hot spot here just a second ago. So yeah, about 1 to 3 degrees above normal for the equatorial regions. And then as we get closer to the Philippines here, just a little bit north of the equator, you have 3 to 4 degree Fahrenheit above normal readings. And those warmer than normal ocean temperatures are helping to fuel that atmospheric river that's flowing across the Pacific as the waters evaporate there. And then you've got this broad region in the northern Pacific that's much warmer than normal, which is also just kind of adding to the whole water vapor picture, because typically, the waters here will be cooler and you tend to have less evaporation, even though, these waters are generally, like if you look at like just general temperatures, you're talking water temperatures in the 40s, 50s, and 60s, but they're 6 degrees warmer than normal. So that increase in relative temperature is going to provide relatively more water vapor and fuel for these storms that are coming in. So just a general overview of the climate conditions for the Pacific. I am going to let the experts make a determination as to what degree these conditions are having an effect on the storms. I'm just generally talking about what we know as far as climate goes and how generally climatic conditions can tend to amp things up here as oceans warm and as land surfaces warm. And the main ingredient there is water vapor and convective lift, particularly water vapor for California. And right now we're seeing that giant river of moisture continuing to stream on in, which is creating those conditions that have resulted in an emergency being declared. And let's go ahead and look at some National Weather Service radar and alerts here. So I'm just picking some locations. So this is Merced County, California right now. under a flood warning, a flood watch, a wind advisory, a high wind warning, and a flood watch, and another high wind warning. So just all these watches and warning coming up for Central California. For the mountain regions, we've got winter weather advisory, winter storm warning, avalanche warning, winter storm warning, and a flood watch. So you just got a potpourri of pretty much everything. All of the major weather advisories there for extreme Western California. Which county was this? This was Mono County in, I guess that's central Western Calaveras. And then for Calaveras County, we've got a flood advisory, a winter storm warning, another flood advisory, another avalanche warning, high wind warnings, flood watches, and another winter storm warning. So just two locations. Let's go down here to, let's see, let's pick one down near the coast here at Santa Barbara. Let's, yeah, go ahead and pick a, so at Santa Barbara right now, we got a gale warning, a marine weather statement, a flood watch, another high wind warning, another gale warning, and a flood advisory, and a beach hazard statement. So, it's just, again, lighting up like a Christmas tree as we get these storms coming in, and this storm definitely really heavily packed with moisture. In the near offshore environment for Central California, we've got gale warnings and small craft advisories for a broad swath. So just all of the various stormy features here in California right now. I do want to look at what we expect, at least as far as precipitation for future. And I'm moving to a 1 day model in the NOAA quantitative predictive forecasts. And so I typically look at 5 to 7 days, and we're going to also look at the 5 to 7 day, but I just want to show you what's expected over the next day for this storm event. And of course, this is a broad brush analysis. Localities can vary considerably. And of course, with any prediction, you can get variance on the top or lower end with any event. But this particular event right now, if you're looking at south central coastline here, near, I believe this is near the Los Angeles area. Let's go ahead. I'm going to actually go back at the National Weather Service radar and confirm that. Yeah, I need to get my geography down, but yeah, Los Angeles area. I was right. But yeah, so near the Los Angeles area, particularly as you get just a little bit inland, looks like maximum rainfall potentials in the range of 3 to 5 inches, maybe a little more. Some of the weather statements we're talking about 1 inch per hour rainfall rates, which are pretty significant. And this is just for one system. For the mountain region, it looks like we're looking at, if you convert to rainfall, in the range of 4 to 10 or more inches, and then converting to snow, this is in the range of 5 feet of additional snow for some of the higher elevations. So this is a very extreme precipitation event in a series of extreme precipitation events for California. This is just the most recent. And it's also worth noting that some regions of California are not getting any rain. So if you look at Southeast California, there's like a dry spot here. And the Northern California region, so at least for today, is getting a little bit less rain. So the main event here for central, the mountain regions and near the Los Angeles area, and then regions just to the north and west of Los Angeles. And now looking at the 7 day, I do want to show you the 7 day totals predicted for California. And it's worth noting that that the extreme high precipitation amounts, at least in these predictions, are coming down just a little bit, but you're still getting a lot of precipitation over the course of a week. And when I say a lot, you're looking at 7 to 15 inches if you convert to rainfall. But a lot of these are for the mountain regions. So for the higher elevations, it's going to be snow. It just depends on where you are. If you're like lower down in some of the valleys, it's probably going to be more rainy, which is one of the reasons why you see a combination of winter storm warnings and flood warnings for these mountain regions. You're just getting all that heavy precipitation in various forms. For some of the coastal regions, you're looking at 7 to 10 inches in some of the hot spots for precipitation. And then up here, up in the northern region, you get that prevalence of stormy conditions, and you get some hot spots in the range of 7 to 10 inches. So still another week of very heavy precipitation predicted for California. And we're getting kind of a main event here right now in California with that extreme weather associated with that atmospheric river. And so please stay tuned to your local emergency bulletins and your local weather service and your national weather service statements for California. And for climate, please stay tuned to your experts that are providing ongoing reports and studies on the impacts of climate change on these extreme weather events. And so thank you for joining me for this latest special edition of the OBX Wave Report. And I didn't say it in my last episode, so I'm going to have to say it now. And please do everything you can to accelerate the transition to clean energy, to fight the climate crisis, and to defend our coastlines, which we all love, particularly those of us who are surfers. So thank